Good morning, my dear students, and welcome back to the fourth class of the online session 2020-2021. I'm very happy to see the way you all are solving the worksheets and sending it to us. At the same time, there are some of you who are not doing their work still. So I request you not to keep any of your work pending. Okay, so that will be a problem for you, and it will be, there'll be a lot of workload later on. So it's better with time, along with the explanations, as I cover up little by little, even you solve your work little by little. Okay, and you send it to us on time. Please do not delay. Okay, so with this, I start with today's lesson. So what are we going to do today? We are going to start with the applications of pressure. Before I start with the application of pressure, I would like to again discuss with you what is pressure. As I told you, pressure is equals to force by area. Pressure is equals to force by area. So once I have written the formula, I can also tell you the different relation among all the three terms. Okay, there are three terms over here: pressure, force, area. So what is the relation among them? Let me see. Pressure is directly proportional to force. Mind it, this is the proportionality sign. Okay. This is how we represent proportional. So pressure is directly proportional to force. What is the meaning of this term? That if force is more, or if we increase the force, automatically your pressure also increases. And if you decrease the force, your pressure also decreases. Okay, so this is directly proportional. There is another term, area. So how is pressure related to area? If pressure is inversely proportional to area, this is how we represent the inverse relation. Inverse means opposite, means if area is less, pressure will be more. If area is more, pressure will be less. Just the reverse will happen. Just the reverse will happen. Is that clear? So pressure is inversely proportional to the area. These are the two important things that you have to know. This is the relation. So from these things you can easily understand why pressure is equals to force by area. So based on these things, this is the key thing to solve any kind of application based question, any kind of question given to you. For example, let me discuss one. It is often, it is very easy to cut vegetables or fruits with a sharp knife than a blunt knife. Why? Why is it easier to cut with a sharp knife than a blunt knife? Do you know the reason? You will get the answer from here. When I am talking about the sharp knife, the area of contact is very what? Less. Sharp knife has lesser area of contact with the vegetable or the fruit. As a result, if the area of contact is less, pressure will be more. And if pressure is more, the effect of force will also be more. Since pressure is directly related to force. So if your pressure is more, your effect of force will also be more. Is that clear? So once more I am repeating this thing. It is easier to cut vegetables or fruits with a sharp knife than a blunt knife. Why? The reason is it comes from here. The area of contact of a sharp knife is lesser. So lesser the area of contact, more will be the pressure, and automatically the effect of force will also be more. Whereas in case of a blunt knife, the area of contact is more. If the area of contact is more, the pressure is less and the effect of force is also less. Okay, so this is one example, a very simple example from our day-to-day life. Another example, let me take. You must have noticed that if the nail, N-A-I-L, supposing this is a nail. If the edge is sharp, it is easier to insert it in a wall. It will easily penetrate a wall. But if this is blunt, it is difficult. Why? Again, you get your reason, your explanation from here. If the edge is sharp, the area of contact is less. And if the area of contact is less, your pressure is automatically more. And if pressure is more, the effect of force is also more. Whereas, if this surface is blunt, like this, supposing it's a blunt surface. Okay, so what will happen? It becomes very difficult for us to insert it somewhere. It becomes difficult for us to insert a blunt nail. The reason is, blunt means area of contact is more. More the area of contact, your pressure is less and the effect of force is also less. Okay, so two examples from our day-to-day life I have given you. There are more examples to put forward. For example, you must have noticed that it is very difficult for us to walk on sand. At the same time, if you go to the desert, it's filled with sand, and the desert animal, the camel, can easily walk on sand. Again, what is the reason? The feet of camel is broader than our feet. As a result, the area of contact is more. More the area of contact, pressure is less, effect of force is also less. Think about our feet as compared to the camel's feet. Our feet is quite what? Smaller. If this is the feet of a camel, quite broad. If this is the feet of a camel, and this is the feet. This is our feet, isn't it? This is our feet. So compared to our feet, the camel's feet is quite broader. So as a result, the area is also more. More the area, lesser will be the pressure. Effect of force will also be less. Okay. At the same time, look at our feet. Our feet is quite shorter, smaller as compared to the camel's feet. As a result, what happens? Lesser area of contact, pressure is more, effect of force is also more. Is that clear? One more example I am giving you. You must have seen athletes. They wear, athletes, then footballers, they wear shoes having spikes. And the spikes, they have pointed edges. Isn't it? And when they walk on the ground, when they run on the ground, these sharp edges leaves, greater impression on the ground. But at the same time, if you're just wearing a slipper and you're walking on the ground, it will not leave much impression on the ground. Again, the reason is same. A spike, if this is the bottom, the sole of the spike, and these spikes have these pointed edges, sharp pointed edges, as a result, the area of contact is less. Lesser the area of contact, pressure is more, effect of force is also more. Alright? Okay. But if you are just wearing a slipper, and you are walking on the ground, it will not leave much impression on the ground. Why? Because the area of contact is more, your pressure is less. As a result, the force exerted on the ground is also less. Okay. So this is what happens. These are some, various examples that you can put forward from our day-to-day life. Some applications based on pressure. So all you have to know is this, the basic. This is very important. You can note it down somewhere. As I am giving you the explanation, this part you can note it down, children, somewhere in your notebooks. Okay? So this concept, if this concept is clear, you can easily, answer any kind of application based questions. So that is the thing. Pressure is directly proportional to force. Means if force is more, pressure is more. If force is less, pressure is less. And pressure is inversely proportional to the area. Means if area is less, your pressure is more. If area is more, your pressure is less. Just inverse, reverse of what happens. One is more, another one is less. Okay, so this is the thing. So any kind of application based questions given to you, any kind based on pressure, you have to identify the area of contact. If you can make out the area of contact, whether it is smaller area of contact or larger area of contact, you are going to easily get the whole answer. Because if your area of contact is less, your pressure is more, and if your pressure is more, your effect of force is also more. At the same time, if your area of contact is more, your pressure is less, your effect of force is also less. I hope this thing is very much clear to you all. Okay, so you can go through lots of questions, different kind of questions. You can go through all these things. Okay, I have given you some examples. One more example I would like to give you. You must have seen porters. Who are porters? Coolie. Those who carry luggages on their head. So these porters, they carry a small piece of, first they wrap their head with a small piece of cloth. And then they place the luggage. Directly they don't place it on their head. The reason is when they are placing a piece of cloth, round piece of cloth on their head, they are increasing the area of contact with the luggage. And if the area of contact increases, the pressure decreases and effect of force, that means the pressure, the force of that luggage, okay, will be lesser, will be reduced on his head. Okay, so this is another example. Another example, your school bags that you carry. You must have seen the straps are quite broader. So why are the straps broader? Why broader? Why not thin straps? Broader straps means the area of contact with your shoulder is more. More the area of contact, lesser is the pressure, lesser is the effect of force. Okay, at the same time, imagine the school bags that you are carrying, they are having, thinner straps, and you are carrying lots of books and everything. There are so many things you carry every day to school, isn't it? So your bag becomes heavy, and once the straps are thinner, they will leave lot of impression. You are going to get hurt. So that does not happen if the straps are broader. I am talking about your bags, your school bags. Okay, so these are various examples from our day-to-day life. Okay, I hope I have made myself clear. You please listen to the explanation carefully. Okay, and any kind of question, as I told you, application based questions, you need to have this concept very clear. Okay, so these are certain examples based on applications of pressure, where you have the effect of force, pressure and area. These three things will matter. Let us move to the next topic, that is pressure exerted by liquids and gases. Right now I am going to discuss about the pressure exerted by gases. Okay, pressure exerted by gases. Pressure exerted by gases. Very common example. You take a balloon. Birthday parties and all, what do? We take a balloon, we blow the balloon. Once we blow the balloon means we are blowing what? We are blowing in air inside the balloon. So when you are blowing air, the balloon automatically gets inflated. Why does it get inflated like this? It is because you have inserted lots of air or gases inside the balloon. As a result, these gases, this air, they exert lot of pressure on the walls of the balloon, and hence the balloon gets inflated. Okay, so this is one very common example. Another example, you can take the bicycle tires. What about the bicycle tires. You need to pump air inside the tire, inside the tube of the bicycle. That means when you are inserting air inside, air is exerting pressure on the walls of the bicycle tube or the tire, and hence it's getting inflated. Okay, so this is another example that air, even gases also exert pressure. Okay, so this is just the first portion. Another we have is pressure exerted by liquids. Pressure exerted by liquids, I will be giving the explanation in the next class. So till then, today you are going to go through the applications of pressure. We have done plenty of examples based on pressure. It's better you write. I have given you questions in your worksheet and you are definitely going to solve it and send it to me. Okay. And your worksheets, the questions, application based questions, don't write huge long answers. I don't need long answers. I need answers to the point. Keywords should be there, just like I have given you my explanation, that if the area of contact is less, your pressure will be more, your effect of force will also be more. So like this you will be explaining it. Is that clear? So this much for today. So go through the lesson once again. We have very few topics left to be covered. Okay, so do your worksheet, send it to me. Thank you and have a good day.